Hello everyone, welcome back to another video. Today we're going to look in quite a lot of detail at the high temperatures this Monday, and also the potential for some pretty strong or even severe thunderstorms across possibly quite a large area of the UK and Ireland. We'll get into that right away with the overview chart, and this is showing the pressure and also the temperature at 850 hectopascals, which is the same as kind of saying 1.5 kilometers above the ground level. And you can see we have the high pressure just to the east of us, a fairly strong low to the west of us, and then a very large pocket of really hot air which has been sitting in this region and being compressed, and so it's heating up. And what happens is that the jet stream is now moving strongly from kind of areas quite far south to areas quite far north, and so brings up this low right here, and then that allows the winds to turn quite suddenly and then advect, which basically means move the very hot air originating from over here into parts of northwestern Europe, including the UK. And actually you can see we have the dark reds showing up on the air mass chart across southeast England during Monday afternoon, which is indicating air at 1.5 kilometers being above 20 degrees Celsius, which is pretty uncommon, or at least it used to be. It's becoming more common now with the climate change. But when this happens, we almost always get fairly high temperatures. However, do note that the air does not extend quite as far north as some other heat waves, especially across parts of Ireland and northwest Scotland. You can see looking fairly unsettled and a bit cooler there. That all gets swept out by kind of Tuesday. Might still be some residual warmth, especially across the east, but the transition between the very warm and the less warm air is likely to bring some thunderstorms, and we'll look at that later. First, quick kind of look at the temperatures here. This is from the UKV model. I generally find this model to be pretty accurate in terms of the temperature, and I'll put the link for this in the description as well. And sometimes it can over or underdo it by a couple of degrees, and also on top of the fact this is 2 days away still, so a lot of time for things to change. But already this model is showing temperatures into the low to mid 30s across parts of eastern England there, with a hypothetical, if this were to verify, hypothetical peak of 34 across eastern England. But still, for a large area of England and Wales, high 20s, and for a pretty large area of eastern England, we're looking at low 30s. And I mean, probably the highest possible we're looking at is maybe 35. Probably not going to go much higher, though I wouldn't completely rule it out. But yeah, definitely looking pretty warm on Monday, though that heat is quite short-lived. But now in terms of the thunderstorms, we're going to take a look at the upper air pattern first. I've just skipped through a bunch of things. But if I show you the upper level chart for 500 millibars, which is around halfway through the atmosphere, kind of 6 kilometers or so, and this will show us kind of the energy and the lift in the atmosphere. And remember, for storms we need pretty much two things: lift and kind of moisture or instability. For severe storms, which is a possibility on Monday, we also need shear, which is kind of difference in wind speed or direction between the lower levels and the upper levels, and potentially we'll have all three of those things, though not necessarily aligned with each other on Monday, but I'll talk about that more in detail. This, though, is showing quite a lot of lift moving into northwestern areas of the UK and Ireland pretty early on Monday. The dark purple and orange colours are showing where there's a lot of spin, which is called vorticity, and generally where the wind is kind of pushing through that, we're advecting it, which is in those regions where the kind of advection of the vorticity is occurring, you can infer vertical motion, which is the fancy word for saying lift. It's rising air, helps storms to form. But you can see that we have quite a lot of it initially across parts of Ireland through the very early hours, and that transfers to the northeast and then kind of into Scotland by, let's see, this is 9 o'clock and should be kind of in Scotland by this time. Let's just see. Yeah, so you can see then it kind of transfers out, and then by kind of the afternoon, it is kind of really exited the UK, and so the influence of this particular system has gone, so it's not going to be really helping to create any more thunderstorms by midday on Monday. But before that time, it does look likely we are going to see some pretty strong thunderstorms. The instability plume will be moving northwards with the strong upper level winds going from south to north, so we'll bring likely some elevated instability into this region. A bit of uncertainty right now on exactly how strong that will be, but definitely enough to support at least scattered thunderstorms. And you can see the simulated radar, so don't take this as a verbatim, it very well may change and will change. The simulated radar from the UKV shows lining up quite nicely with that last chart. Where the lift is, we're getting thunderstorms developing, possibly quite strong, bringing the risk of heavy rain and lightning, and then potentially organising into Western Scotland through the early hours of the morning and then exiting kind of by the afternoon. Some models do show that extending further south, so it's potentially we could be seeing storms even across kind of parts of Wales and further south in the Irish Sea by kind of late morning on Monday. That I'm not particularly sold. I've only seen a couple of models do that. But the kind of thunderstorm risk then transfers to areas further south associated with this very, very warm air, because not only will the air be warm, but it will also be quite humid. And so warmth and humidity generally lead to instability, and that is pretty much the energy for storms. And in terms of instability, right now it's looking like there could be quite a lot of it. If I show you the European model's Cape chart, so like I said, there's a lot of room to change, especially in kind of terms of thunderstorm forecasting. That's generally more uncertain. But the European model is showing very large values across parts of England and Wales associated with that plume of humid and unstable warm air. Generally values over 1,000 in the UK, more than enough for storms. Anything over 2,000 is pretty rare, and you can see we've got very, very high levels across kind of parts of the Midlands, and that generally tracks northeastwards through the afternoon. There's not quite a consensus on exactly the areas which will see the most instability now, but it's generally thinking this sort of region outlined in red here between all the different models. Some have it further east, some have it further west, but those kind of trends will be confirmed closer to the time. Remember, we're still 2-3 days away. If I take a sounding though, we'll show you some of the issues with the forecast in terms of thunderstorms, because you might be thinking, well, there's lots of Cape, surely there's going to be loads of thunderstorms. That may be true, and actually you can see we have a very, very large region between the red and white dashed lines indicating a lot of energy, but there are a couple issues. Number one, it may be too dry. Now, we've kind of seen a slight shift in it being more moist over kind of the last few model cycles, but it's possible that the dry air will kind of eat away at any updrafts trying to form and actually destroy them. That's called dry air entrainment, and that's probably going to be more of an issue further south because of, let me take a sounding further south here. If I take one across Kent, you'll see there's a lot more dry air. Just wait for this to load. Yes, you can see there's a lot more dry air too. And then also notice the thing I was about to talk about next is we have this inversion showing up on the temperature line, that's the red line, and that's also known as a cap, and that's basically a lid on any storms trying to develop. And it essentially means, yes, we've got all this instability, we've got all this energy, but potentially there's going to be a big lid on any storms that do form, and so they won't be able to get to this point of using the instability, and it's basically going to be cloud-free, no risk of storms. And that's definitely looking likely across kind of the south. I'll draw a rough area, but this region here, yes, there's a lot of Cape, but because the cap is so strong, it's not looking likely that storms will develop. If I go further north, you can see that becomes less of an issue, and so it's a lot more marginal, it's a lot more conditional, because also the thing is, storms may not form, but take a look at this wind profile. This is one of the better kind of forecast environments I can ever really remember in terms of thunderstorms across the UK, in terms of kind of supercells and even the risk of tornadoes. I don't really want to say it because, like I said, there's a decent chance storms don't form, but you've got that curved shape in the hodograph, especially in the lower levels. This is kind of below 2 kilometers, this region here. That's a lot of low-level shear, helps low-level rotation, but also notice the upper levels are fairly strong as well. We've got almost kind of 40-50 knots of shear there, which will help the updrafts separate, and then potentially that can help kind of supercells and more organized convection, which is generally more severe. And actually, also notice in this particular sounding, we have much better low-level moisture and pretty much no cap. So I would almost expect storms to form in this sort of region here, at least on this particular run, but other models like the Icon have a lot more capping, so it's generally pretty uncertain. And also the actual lift itself might not be present to kind of really get things going because this main trough has exited. So yes, we have this very impressive environment that would hypothetically support severe storms kind of across Wales, Midlands, Northern England, but if all the energy is removed to the north, they might not even form. The one thing to look at though is this potential disturbance on some of the models. This is the same chart as before, the vorticity, but except it's much lower levels. So kind of perhaps more smaller, more subtle features, which kind of you don't immediately see at first sight, and also perhaps don't become evident until closer to the time. But what this is showing is a very slight disturbance through kind of parts of Northern Ireland, Wales, and then that eventually moves into Northern England and parts of the Midlands later on. And this is present on most models I've seen. For example, the GFS has it, though notice how, like I said, there is uncertainty. This time it's slightly further east. The Icon also has it further east, even further east than the GFS2. So any chance of storms is probably going to be associated with this. This could maybe just tip things in favour of storms developing, and if they do, then this corridor of kind of the Wales, North Midlands and Northern England could see pretty big time storms, lots of lightning, lots of rain, maybe even hail, maybe even something more. But we're just not at that stage yet where we can confidently say that, because so many of the models actually show nothing. If I show you the kind of forecast precipitation, if it even loads, that is, I mean, I'll just tell you now. Okay, here we go. Yeah, this is good. So the GFS, it does actually show stuff, not a lot, but you can see those kind of clusters of blue. Those probably would be storms. However, if we compare that to the Icon, and like I said, I don't know if this is going to load, but the Icon pretty much has nothing. So there's two kind of split scenarios, and the implications are quite big, because one is looking at high impact storm event, the other is looking at pretty much nothing. So it's really about figuring out what's going to happen. We also could look at convergence zones for kind of any help. For example, the European model has a slight convergence zone here and a lot of moisture pooling together. So this possibly the combination of the smaller disturbance, the convergence, and the slight better moisture further north would suggest that we might get storms here. And my personal opinion is if, and only if, this European was to verify, we would get pretty strong storms in this corridor here. But the difference is the Icon is everything is further east, and so by the time that the temperatures are highest, by the time that we have the most instability and the least kind of cap, things have already moved off to the east. So we wouldn't really be looking at any storms with the Icon. GFS is somewhere slightly in the middle. So really it's about kind of seeing which of these scenarios actually comes to fruition, and then from there we can kind of talk about more in detail what's going to happen. One thing is for sure though, not for sure, but looking very likely, storms in this region, and then the secondary region, which is this level 2 I've got here. Let me highlight that there. This level 2, this is the more conditional region, and hence we've got the black dashed line to indicate where those storms might be severe. So I'll do another video tomorrow and on Monday, just to kind of give another update on what's happening. But if I were anywhere in this kind of zone here, I would keep a very close eye on the forecast, because the potential, and it's just potential this time, but the potential is there for pretty strong thunderstorms, but depending on whether we get enough convergence and enough from this disturbance here to trigger things in the direction of allowing storms to develop and utilize that quite potent atmosphere. But that will be enough from me for today. Thank you very much for watching, and have a good afternoon. Bye-bye.